Well, hello, matriculants. It's the 10th day of lockdown, my true love said to me. I feel like singing that Christmas carol. It is the 10th day of lockdown. Maybe we're getting all bushy and sort of cabin feverish. Anyway, to cure this cabin fever, let's have a look at this section of the grade 12 syllabus. Solve conservation of energy problems with dissipative forces present using the equation work non-conserved equals change of kinetic energy plus change of potential energy. So if you go to our BFF, best physics friend, let's move that along there. There is our there's our definition of work, and there's our work-energy theorem. Work net equals change of kinetic energy. And here we see change of kinetic energy is kinetic energy final minus kinetic energy initial. And we can say the same thing for potential energy. And then there's another little formula here. Work non-conserved is change of kinetic energy and change of potential energy. So we're going to solve the problem, we're going to either use that formula or our classical work-energy theorem. Okay, so let's go and find a problem from a past paper. So here is a problem from a past paper. Let's move it along a little bit. Okay, let's just read from here, because we can ignore the rest of it. Our problem basically starts. A block moves from point B at a velocity of 4,95 meters per second up a rough surface. Do you see that surface is all jaggedy? Inclined plane to point C, so it moves from B to C. The speed of the block at point C is 2 meters per second, so it's still moving at point C. Point C is 0.5 meters above the horizontal, as shown in the diagram below. Using its motion from B to C, a uniform frictional force acts on the block. State the work-energy theorem in words, and then use energy principles to calculate the work done by the frictional force when the 2 kilogram block moves from point B to point C. They asked us to define the work-energy theorem, and it says this is the theorem that formula is defining. The net or total work done on an object is equal to the change in the object's kinetic energy. There it is. The net work done is equal to change of kinetic energy. So here's our problem taken from the November 2016 paper 1. Here's our block. It's going up a slope. We don't know the length of the slope. Its initial speed is 4,95 meters per second. At point C, it's going 2 meters per second. We're asked to find how much non-conservative work was done, or work due to friction. So this is the formula that we are given. It's on our data sheet. Let's work it out. So let's just unpack some of these things. Work non-conservative is work done by friction equals, what's the change of kinetic energy? It's going to be EK final minus EK initial plus change of potential energy, EP final minus EP initial. Again, we unpack our formula further. It's going to be a half mv final squared minus a half mv initial squared plus mg h minus mg h, where h is the final height and hi is the initial height. Right, so let's plug in our values. What is the v final? Well, let's put our values. Shall we put them, let's say, here. V final equals 2, V initial equals 4,95. Height initial is, if we take that as our baseline, it's got 0 height. H final is going to be 0.5 meters. Is there anything else? G is equal to 9,8. And M is equal to 2. So let's plug in our values. A half times 2 times V final 2 squared minus a half times 2 times V initial squared, which was 4,95. 4,95 squared plus MGH final. MGH final, well, let's just go down here a bit, is going to be 2 times 9,8 times H initial, H final, 0,5 plus MGH initial is going to be 2 times 9,8 times H initial, had initially no height, which was 0. So half times 2 is 1 times 2 squared is 4, minus, those two cancel out, 4,95 squared, 4.95 squared is 24,5 naught plus 2 times 9,8, 2 times 9.8 times 0.5 equals 2 times 9,8 times a half. I guess that cancels that, so we're left with 9,8 plus 2 times 9,8 plus 0. So what have we got? And that gives us an answer of minus 10,7. What is it measured in? Joules. Are we surprised that frictional force or force acting against something ends up with a negative value? No. There's our answer. Easy peasy, chicken squeezy. Just plugging in our values, as long as we write and we keep clear of what they are, we can use that formula. The other formula we could have just as easily used was work net is change of EK. And that we could have also used that formula or our Work-Energy Theorem formula, and we would have got exactly the same answer. What I'm amazed at when you see this coronavirus outbreak is how little scientists know. If everybody wore a face mask, it would be like social distancing on steroids. We must all wear face masks if we go out. This is science, guys. It's not hard to do. How hard is it to get a piece of cloth and put it around one's face when one goes out? It's not going to stop you from getting the virus, but it's going to stop you spreading it to other people, especially if you're asymptomatic. And they can't even answer questions like, why do babies get it so lightly? What is it about some people? Eventually science will find the answer why some people get it badly and some don't. So the world is waiting on the scientists. It's waiting on you guys.